Okay, so if we look at the memo here, we can see that our first question in our memorandum was simply to prove this, which we've already looked at. Remember that proof? For 6 months. Lovely, huh? It's not a difficult. I had to look for where am I going to get marks for 6 marks. So that was really lovely. Let's look at the next one. Okay, so they say, given this, write down the first 3 terms of this series. How would you go about doing that?
Just substitute the I.
Okay, and then we should get. And again, if you put commas in between, it's wrong, because the first 3 terms of this series.
I think I got it wrong, okay? Because I didn't know the plus. Yes.
That's what series means. It's a plus. You can't.
Can you give me 1.5?
It only counts 1.
Hey. Oh, it's not bad.
You only laugh. Okay. Now show that n can be expressed in terms of s as that.
Hint.
Hence, the right-hand side of the original equation represents a series. So guys, don't let this fool you. Don't let this intimidate you. What is this? Sum of what type of sequence?
Geometric, because the I is on top.
Geometric if the I is on top. So what should be the formula? So if I wanted to replace this with a formula, what could I use? Okay. So in other words, we could say that S is equal to a. What's the formula for
Times
1 minus r. So let's substitute, because look here, all they ask is for n, to solve for n, get n on its own. So that's all we have to do, and we simply have to substitute a and r. So a is 6 and r must be 5, because I'm multiplying. Well, there you could see it. A is 6 and r is 5. Okay, so a is 6 and r is equal to 1 minus 5 to the power of n over 1 minus r is 5, so this is minus 4. So I multiply both sides with a negative 4 to cancel this, and I divide both sides with a 6 to cancel the 6. So I'm left with negative 4s over 6 is equal to 1 minus 5 to the power of n. So what next? What is the aim of solving an... No, what is the aim? We're trying to solve n. When I'm trying to solve an exponential, an unknown in the exponent, what is my first process? What? We want base exponent equal to answer. So I want my base exponent by itself, which is? What am I trying to get by itself? 5 to the power of n. So if you want to, then put it as a k. Remember that. Put it as a k. So 1 minus k. So k is equal to 1 minus 4s, which gives me plus 4s over 6. But k is not really k. K is actually 5 to the power of n. Okay, are you with me? I took the k that side and this one side. Okay. And now, can I use logs? Do I have base exponent equal to answer? Yes, then I can use my logs. My log says my exponent is equal to my log, same base, and whatever is on this side goes inside the log. 1 plus 4s over 6. Now let's just see where I'm supposed to get to. I'm supposed to get 4s plus 6 minus log 5, 6. Okay, I'm not far from there, you see? I'm not far from there. I've got something going. So there's a log law that says when I have log, if inside my log I have an a over b, I can write it as log a minus log b. Okay, there's one log law that says that. So I just don't have a fraction in here. I've got terms, but I can add the 2 by saying this is 6 over 6. And then I get log of 5, 6 plus 4s over 6. And there I go. Log 5, 6 plus 4s minus log 5, 6. Okay. So, but that's okay. It's not, if you didn't get that, that was a good, how many marks? Well, let's see here. I gave 1, 2, 3, 4, 5 marks for that question. So it's a big question. Now, hence or otherwise, find the number of terms in this series. So you could have done it in a different method, okay? But it only counts 2 marks. But still, you have a formula here. We've worked out a formula for the number of terms. So they give me s. So all I do is I substitute in there. So literally just take that value, substitute. If they say hence, then just look at your previous question. You probably have the formula already. Okay. Hence, do I say it wrong?
No.
What? I don't? Yes. I say hench actually as well when I read it. That's probably why I spell it hench. Hence. Hench. Okay, how do you spell hence? H-E-N-S-E. Oh, you laugh. You don't even know how to spell it yourself. Okay, so here we go. All we do is we substitute this in there. And then I see I get 4. When I solve it, I get 7. No, you should get 7. Okay. Okay, next question. Oh, here's a similar one. Consider the quadratic sequence. How about your turn to do this one? Me quickly just show you how we work this. So obviously we take our first difference is simply the x minus the x minus minus 17 is x plus 17. The 7 minus x, 7 minus x, the y minus 7, and the 55 minus y. Then we take these two to get our second difference. So here's a sequence of second differences. Okay, which is 7 minus x minus 17. So 7 minus 2x's minus 17. Then that was taking the first 2. Now taking the next 2. Okay, I get y minus 7 minus 7. So I'm subtracting 7 twice. Minus x gives me plus x. So I get y minus 2 of these. It's just how the computer marks it, but it's 14. Y minus 14 plus x, and then the final one is these two. I get 55 minus y minus 7, which is plus 7. So 55 minus 2y plus 7. So this gives me now 3 expressions. Each of these expressions represent a second difference, and any combination, any 2 of them together will give me an equation because they have to be equal. So I can say the first one and the second one, or the first one and the third one, or the second one and the third one. So there were 3 I could have made. So I just take the first one and the second one and the third one. That gives me 2 equations, and this is quite a challenge to solve them simultaneously. It's a lot of work, and the whole time you must just keep a cool head. so that you don't make mistakes. So a small mistake can have bad consequences. So, okay, so there we go. This is now the way that we gave marks. Is I gave a mark for finding the second difference, a mark for using the second difference for using the second difference equal to find equations. In other words, you know the property that the second differences are equal. So that's the second mark. Finding a correct equation and finding another correct equation, and then one for each answer. Okay, let's just look at the last question. An architect is designing a theater. The first row of seats in the seats from the front has 18 seats. The second row has 20 seats. The third row has 22 seats. So what do you see? What's the pattern? Plus 2 every time. If the pattern continues, how many rows of seats must the architect have in the theater so that it can hold 600 spectators? So what is the 600, or hold at least 600 spectators? What is the at least, what does the 600 represent? Sorry? What does Tn represent in this equation, in this story? So the whole challenge is to get out of the context. So you're just guessing Tn. What does T represent?
T. I don't understand.
So we get T's and S's for A's and N's, and so what does N represent in here? So for example, what type of sequence is this? First of all, we've got 18, 20, 22. What is 18 in the story? 18 is the first row. So this is one row, 2 rows, 3 rows, isn't it?
Yes.
And this is, and 18 is the first row of what? What does 18 represent about that row? Seats. So there's 18 seats in the row. So T1 is 18. T2 is 18. 20. T3 is 22. He wants something to do with 600. Does he want a row with 600 seats? Is that what it says? He says, if this pattern continues, how many rows of seats must the architect have in the theater so that it can have at least 600 spectators?
Oh, so 600 is not TA, it's the N in this case, because TA, listen.
No, I'm listening, sorry. But you were saying it's N. What was N again?
No, but it was right in the beginning. It is TA. Look, this
Yeah.
T1 equals 18.
What is T1? Just explain to me in the story.
In the story, it's the first row.
It's the
18.
number of seats in the first row is 18. Yeah.
18. So how, in order to have 600 spectators, at least 600 spectators, you need to have at least 600 seats. You understand?
In a row.
Not in a row. in the theater.
In total.
Yes.
In other words, row 1 plus row 2 plus row 3. So is 600 TN. Yes. Yeah.
Close.
They are complete. That is exactly what we were testing in the question. Is, do you know what the 600 represents? It represents, again, we get out of the, we don't just see 600, oh, that must be TN. Okay, we must try and reason it out. You see how thinking came into play here? Okay, good. So, and again, an important thing is you lost the mark if you didn't see that Sn must be greater or equal to 600. Not equal to 600, greater or equal, because it says at least. Okay, so Sn represents the sum of an arithmetic series. So I'm taking the total people in row 1 plus the total people in row 2 plus the total. So that means it is n is what I'm trying to calculate. How many rows must I have to have at least 600 spectators? So n over 2, 2 times 18 plus n minus 1 d, constant difference is 2, is greater or equal to 600. So now when I solve it, again, remember I multiply on both sides with a 2, so I get 36n plus 2n squared minus 2n is greater or equal to 1200. Okay, and then this time it wasn't necessary to multiply the 2, because if I just multiplied it in, the 2's would have cancelled. So I should have done that actually. And then I would have gotten 18, or well, let's just do it now. So I've got 2n squared, so I've got 2n squared. 36 minus 2 is minus 34n plus 34n plus minus 1200 is greater or equal to 0. And then here I get n squared plus 17n minus 600 is greater or equal to 0. Can you get me my 2? So remember, this is an inequality, so it looks like that. I want my 2 intercepts. Do you mind getting it? It's a positive 17, yeah.
I didn't realize it was equal.
So 17.43. No, that's right. Negative 0.43. Okay, so now listen carefully. This is an inequality. You didn't have to solve to proper values. Now let's just use our equality, which must be greater or equal to 0. So we're using that side and that side. So in other words, n is greater or equal to 17.43, or n is less or equal to negative 34,43. Now, it was never supposed to work out to a nice number. It didn't ask how many seats must there be to be 600. We want more than 600. So there's no way to have exactly 600. Then we would have had a perfect answer here. But I must have more than 600. So how many chairs must I have? What's the least number of rows that I can have so that there's more than 600 people?
The least number is 3. No. Let me see.
Sorry? 18. Because I want at least 600. If I take 17, then I'm somewhere here. Then I have less than 600. So this is 600 chairs. If I have this many, I will have 600 chairs. But this is not a valid number of chairs or rows. If I have 17 chairs, in other words, now I'm less than 17.43, then I will have less than 600. If I take 18 chairs, then I will be more than 600. You see, this side once again doesn't make sense. It doesn't make sense to talk about negative numbers. Okay, but this is basically saying I should have 17.5 rows of chairs. So in the 17.5 row of chair, I would have 600 chairs, but I'm not making half rows. So it would be the 18th row. So I have 17 rows and another half a row. That would give me 600, but I'll obviously fill up that row with more chairs. So I'll have 18. Does that make sense?
Yes.
Cool. That's it. Thanks.